Hello and welcome back to IXL tutorials. This is Mr. Duffick, and today we are doing IXL T9, which is surface area and volume of similar solids. So this is very similar to an IXL over in the S series that basically gives you two different shapes, two similar shapes like here, and it tells you to find the area of one if they give you the area of the other or something like that. And this is very similar in the sense that you're going to be comparing two similar shapes, but we're dealing with surface area and volume here in these problems. And the reason why I bring up the last problem, the last IXL that we did in the S's, is because you really only needed to know one principle there. And the principle was that if the two shapes were similar and you were trying to find the perimeter, let's say the shape increased by a factor of 2, so it doubled. Well, that means the perimeter would also double. Okay, so if the dimensions doubled, the perimeter doubled. Now that's for perimeter, that's for one-dimensional stuff. For area, for two-dimensional stuff, that means if you're going to double the dimensions of the shape, the area would increase by a factor of 4. So it's 2 squared. Okay, so you're always going to be squaring your factor when it comes to area, which is what we're going to be doing for surface area here. Now, as you might imagine, volume is 3 dimensions, right? Which means if a shape is going to get twice as large, that means our factor is going to increase by 2 to the third power, or 2 times 2 times 2, which is 6. Okay? So with that in mind, let's look at the problems below here. And it says the figures are similar, okay? And we go from small or from large to small. We have this cylinder here, we go down to this cylinder here. And so what is the surface area? So we're going to take the corresponding sides here. The corresponding dimensions are going to be the radius of 2 for our first shape and then a radius of 1 for the second shape. Okay. And we are going to go 2 yards over 1 yard. We're going to make a ratio between both of the corresponding sides. Now, because we're dealing with surface area, we're going to be squaring our ratio. Okay, so 2 squared is just 4, right? Which means there's going to be a factor of 4 difference when it comes to the surface areas. So if the surface area of our second cylinder is 25, multiply that by 4, and so we know the surface area of our first cylinder, our larger one, is going to be 100. Okay? So we are going to come down here and type in 100. So now we have a problem here once you get to a SMART score of 36. That just asks you for the ratio between the shapes. So I'm going to do ratio from left to right. We'll do 8 to 6. Okay. We want to reduce this, so we can reduce both by half. So that's 4 to 3. Okay. But remember that we're dealing with volume here. It's asking for the volume. So we're going to triple both of those. So 4 times 4 is 16, then 16 times 4 again is going to be 64. And then 3 times 3 is 9, and then 9 times 3 is 27. Okay, so we have our new ratio is 64 to 27 for the volume. And can we reduce that any further? Not really, right? 27 can be broken down to 3 times 9, or 3 times 3 times 3. 3 doesn't go into 64, so we're going to leave that alone. Okay, that is correct. Another ratio here. Now it's surface area. And so same deal. We're going to go 2 to 5 ratio. And because we're dealing with surface area, we're going to have to square that. So 2 squared is 4, and 5 squared is 25. Okay, can we reduce that down any further? No, 4 doesn't go into 25 at all. So I'm going to choose correct. Okay, so you get the idea. Let me go back and see if there's a volume one that I can do real quick. Here, okay, so I just found a volume one I can now do. So we have an example for both. So I'm going to go back, and we're going to find the volume of the second shape here. Okay. So we are going to first write our ratio. It's going to be 2/4, which is just 1/2, right? And then our ratio is going to have to be tripled, or done to the power of 3, right? Not tripled, done to the power of 3, because we're dealing with volume, right? 3 dimensions. We're going to have to triple it. So 1 cubed is going to be 1, and 2 cubed is going to be 8. So the ratio is going to be 1/8 between both. So we're going to do 1/8 divided by the 27. If you're confused as to whether you multiply or divide, just think about it this way. If you multiply by 1/8 with the 27, that means the volume is getting smaller. Clearly the shape is getting larger, so we can't divide the we can't or multiply 1/8 here. We're going to have to divide, because that means you're really just multiplying by 8. So the shape is going to get bigger here. Okay, so think about that. See if it makes logical sense. So with that in mind, we'll go 27/1 times 8/1, right? Because we flip the fraction. And so 27 times 8 is going to be equal to 216. Over 1, which is equal to just 216. So the volume of our second shape is going to be 216. Okay, and there you go. So I did surface area, I did a volume, I did a couple ratios. I'm going to jump back up. 60. Nothing different here, just asking for the volume ratio again. Just going to be 3/5, and then you cube the 3 and cube the 5. Okay, what is the ratio of here? So now they give you the volume, and they're asking you to find the length. Okay, so we'll do our ratio here. We'll do 27 to 125. 125. And this time we're going to work backwards. So since we're dealing with a volume, right, they give us the volume. That means these are already increased by 3 by cubing our lengths. And so we're going to do the opposite. We're going to do cube root both sides. And what cube root looks like, just to kind of give you an idea of what we're doing here. Okay, let's say we have 27 and we want to cube root it. It's like a square root, but it has a little 3 here. Okay, and that just means with a square root, we figure out what times itself is 27. If we're cube rooting something, that means what times itself again equals 27. So what times what times what equals 27. And of course, it has to be the same number. Okay, so you wouldn't be surprised to learn that x is 3. 3 times 3 times 3 equals 27, right? 3 times 3 is 9, and then 9 times 3 is going to be 27. So therefore, the cube root of 27 is just 3. Okay, and so we're going to replace this 27 with 3. And now we're going to do 125. So we'll go over here. We're going to cube root 125. So what times what equals 25? That's going to be 5 times 5 times 5 is 125, right? 5 times 5 is 25, and 25 times 5 is 125. So that is going to be 5 then. So we'll go back down here and write 5. So really our ratio for the length is going to be 3 to 5. Again, we just worked backwards here from compared to the last problem, or that last ratio problem. We're working our way backwards. That's why we did the cube root. If there was a problem and it asked for the surface area, it gave you the surface area and then asked for the length of a side, then you're just going to square root both numbers, right? For volume, we're doing cube root because these are volume. So we have a 3 to 5 ratio. 3 to 5 ratio. Okay. If the ratio of the rectangular prism's volume is 1 to 27, what is P? Okay, same kind of problem. Take this. Okay, so it says the volume ratio is 1 to 27, so that's what we just found, or that's the kind of problem we just did. So now it's asking for just one of the sides here. Okay, so we'll cube root both sides. We'll cube root 1 and cube root 27, right? Well, 1 times 1 times 1 is 1, so that's just going to be 1. And we already did this. It's going to be 3. 3 times 3 times 3 is 27. So the ratio between the sides is going to be 1 to 3. Okay? So that means we're going to multiply 6 by 1 over 3. And that means we're going to multiply the 6 by 1 over 3. And that leaves this side length over here as 2. Okay. So we'll go back. We'll type in 2. And that's going to be correct. Okay, so I think you get the idea here. I'm going to skip to 94 just in case. And yep, if the ratio is this, what is going to be K? So same deal here. Okay, so I'm going to end the video. Stay safe, study hard, and I will catch you later for the next IXL tutorial video. Goodbye.